In our previous lesson, we looked at setting up trigonometric ratios for right triangles. We looked at the mnemonic device of SOHCAHTOA. So as a reminder, this is how we spell SOHCAHTOA, and that refers to sine. The sine of an angle is equal to the opposite leg over the hypotenuse. The cosine of an angle is equal to the adjacent leg over the hypotenuse. And the tangent of an angle is equal to the opposite leg over the adjacent leg. And if you recall in that lesson, we just simply learned how to set up these ratios. We did not look at actually using them to find any information, finding missing sides or angles. So today we're going to look at finding the missing side using these trig ratios, and then in a future lesson we will look at finding a missing angle. Just to recall, let's look at setting up the trig ratios for this triangle. First of all, we only have 2 of the 3 sides, so that means we're going to have to find the third. And remember that I can find the third side of a right triangle if I use the Pythagorean theorem. So I'm going to use 2 squared plus b squared equals 5 squared. So 4 plus b squared equals 25. B squared equals 21. So that means that b is going to equal the square root of 21. Alright, so now that I have my third side set up or labeled, I'm going to go ahead and set up these trig ratios. So sine of angle A means I'm using this as my reference angle. So sine, remember, is opposite over hypotenuse, so I've got 2 over 5. Cosine of angle A is adjacent over hypotenuse, so remember adjacent is right next to. And then tangent is opposite over adjacent, 2 over the square root of 21. Now, there is a rule that states that you cannot leave the radical in the denominator of a radical in the denominator of a fraction. And we will look in the future at simplifying this by rationalizing the denominator, but at this point we're just going to leave it because if we're going to actually solve for a side or an angle, and then it doesn't matter, we can just plug that right into our calculator. So we'll leave that there for now. Sine of angle C, now I'm going to use this angle over here as my reference angle. Sine of angle C is opposite over hypotenuse, so that's going to be square root of 21 over 5. Cosine of angle C is adjacent over hypotenuse, so that's going to be 2 over 5. And tangent is opposite over adjacent, so that's going to be square root of 21 over 2. Now I want you to notice that there's a relationship between these two and these two. Notice that the sine of one of the angles is the same as the cosine of the opposite angle. Now, one thing to notice is, let's say that angle A is 50 degrees. And then automatically I know that this is going to be 40 because these two angles have to add up to 90. If this is a right angle, in my triangle I have 180 degrees, that means that the two left over have to be complementary. They have to add up to 90 degrees. So these two, angle A and angle C, or those two opposite angles, are always going to be complements of each other. So the sine of one of the angles is equal to the cosine of the other. Same thing here. The sine of the one angle is equal to the cosine of the other. So when I look down here, if C is equal to 20, angle C, so let's cross that out and put angle C, actually angle C equal to 20. Alright. If angle C equals 20 degrees, then it asks me the cosine of C is equal to what? Well, if this is 20, then that means this is 70. So that means that the cosine of this angle, if you recall, is equal to the sine of the other angle, or the sine of the complement. So that would be angle A. We'll hit this again in the future, but I just want to throw that out there based on what we saw yesterday in our previous lesson on setting up trig ratios. Alright, so now that we've reviewed setting up trig ratios, let's go over finding the missing side using trigonometry. If you notice in this triangle, I'm given one side and one angle. Previously, we were able to find the missing side of a triangle as long as we knew two of the three sides, and we could set up using the Pythagorean theorem. Now we're going to set up using our trigonometric ratios. So notice I've got to decide, am I going to use sine, cosine, or tangent? I'm not going to use all three. I'm only going to need to use one. And I'm going to choose which one I use based on what information I'm given. So in this, I'm given this angle. I'm looking for the opposite, and I have the adjacent. So of my three trig ratios, sine, cosine, and tangent, which one uses opposite and adjacent? That would be tangent. So now I'm going to set that ratio up as the tangent of the angle, and now I actually have that angle measure, is equal to the opposite side over the adjacent side. Alright, so now basically I have, if I put this over 1, I have proportions. And I can go ahead and cross multiply. So I've got the tangent of 55 times 20, so I'm going to write that down. 20 times the tangent of 55 is equal to x. So all I have to do is put this in my calculator, and that will give me the answer for x. Because remember that the tangent of this angle is equivalent to the ratio of these two sides. So that's why I was allowed to set that up. So in my calculator, first thing I need to do, again, we did this in class, but I want to make sure that my calculator is in degree mode. So notice how degree is highlighted right here. If radian is highlighted, make sure you arrow down and then over to degree and hit enter so that degree is highlighted. Alright, so going back, now I'm going to put this into my calculator now that I know I'm in degree mode. I'm going to do 20 times the tangent of 55 degrees and hit enter. That means x is equal to 28.56, and it asks me to round to the nearest tenth, so that's going to be 28.6. This side is in meters, so I'm going to label this as meters as well. So again, we set up our trig ratio, which is what we learned yesterday, but now we're actually solving for a missing side. So let's look at another example. It asked me to find the missing side, round to the nearest tenth, so essentially I'm doing the same thing I just did. I'm going to set this up based on what I'm given. Again, I have this angle, I have the opposite, and I'm looking for the adjacent. So I'm going to use tangent again because tangent is the trig ratio that uses opposite and adjacent. I'm going to set it up as the tangent of 72 degrees equals 80 over x. Again, I've got proportions, so I can go ahead and cross multiply. So I've got x times the tangent of 72 equals 80. And then to get x by itself, I need to divide by the tangent of 72 on both sides. So in my calculator, I'm going to put in 80 divided by the tangent of 72, and the answer to that is going to be this side length. So let's look at this. I have 80 divided by the tangent of 72. Whoops. 72. And I get 25.99. And since I'm rounding to the nearest tenth, if I've got 25.99, this is going to round up. So it's going to be 26 even. And again, my units for this, feet. Setting this one up, I've got this angle, I have the opposite, or excuse me, I'm looking for the opposite, and I have the hypotenuse. So according to SOHCAHTOA, sine uses opposite and hypotenuse, so I'm going to set that up as the sine of the angle equals opposite over hypotenuse. Set up my proportions and cross multiply. I have 283 times the sine of 24, and that's equal to x times 1, or just x. So in my calculator, I'm going to type in 283 times the sine of 24 degrees, and I get 115.1. And that is in meters. So again, we're setting up our trig ratios like we did yesterday, but now we're actually solving for a missing side. Here is my angle measure. I'm given the adjacent, and I'm looking for the opposite. So cosine uses adjacent, adjacent, and I'm looking for the hypotenuse. Cosine uses adjacent and hypotenuse. So I'm going to set this up as the cosine of 45 degrees equals adjacent, which is 20, over hypotenuse, which is d. Set up my proportion, and I can cross multiply. D times the cosine of 45 equals 20. Divide by the cosine of 45 on both sides. So in my calculator, I'm going to put 20 divided by the cosine of 45. So 20 divided by the cosine of 45. And I get 28.28, so we'll round that to 28.3. So 28.3 feet. In this triangle, I'm looking for the opposite, and I have the hypotenuse, so that's going to use sine. So I've got sine of 23 equals opposite over hypotenuse. 14, when I cross multiply, 14 times the sine of 23 equals y, so that's what I'm going to type in my calculator. 14 times the sine of 23, and I get 5.5. This one doesn't have any units, so I'm just going to leave it as 5.5. I have opposite. I'm looking for adjacent, so that's going to be tangent. So tangent of 75 equals opposite over adjacent. Cross multiply. I'm cross multiplying that way. So divide both sides by tangent of 75. Type that in my calculator. 25 divided by the tangent of 75, and I end up with 6.7. Last example, set this up. I have this angle, I have the adjacent, I'm looking for the adjacent, and I have the hypotenuse, so that's going to be cosine. So cosine of 46 equals adjacent over hypotenuse. Set up my proportion, cross multiply. In my calculator, I have 17 times the cosine of 46, and I end up with 11.8. So M is 11.8. In our next lesson, we are going to look at finding the missing angle in a right triangle using right triangle trigonometric ratios.